get on to some fancier tricks. I am not going to use the data compression trick from the previous demo in this one. You can apply data compression to the types of indexes I'm going to show you in here. So that could be used. You are welcome to do it if you want to, but I only wanted to show that particular trick once. Now we're going to focus on how we can use different kinds of indexes. One thing that you may have thought about doing is creating an indexed computed column on the table. Our query is saying we want to compare two columns, and we can create a computed column on the table that performs a comparison between other columns. So I can say I want to alter the table and add a column that I have named first equal last. For this computed column, I've decided to do a case statement. I've said case, when first report year equals last report year, return 1, otherwise return 0. In this case, I have said I want to, when I create this column, I want you to persist it to disk. I have a choice. I don't have to do this. When I create a computed column, if I say persist the computed column, it will actually write it down in the structure of the table. And that means that when we read this column, SQL Server can potentially not redo the calculation every single time. Now, I say potentially. You might think, well, wait a second. If we've persisted it, shouldn't it never need to redo shouldn't it only need to do the calculation upon write? Well, one would think I have a link for you later that there are times when you'll see in your query execution plan, you'll see a compute scalar and you look at it and you're like, wait a second, that's a persisted computed column. Why are you doing a compute scalar on it? Computed columns don't always work the way we think they will in the optimization process. But in this case, I am going to say persist it to disk. And then I'm going to create an index on the computed column and other columns as well. I have said I want to index first equal last. That is the leading key in my non-clustered index. It is followed by total name count. I am including first name and first report year. This index, to create an index on a computed column, you do not have to persist it. You can index a computed column that hasn't been persisted, and we'll see that in a minute. In order to either persist a computed column or index a computed column, however, the column, the definition of what you're computing in there, it does need to be what's called deterministic. And by that, it means that SQL Server needs to believe that anyone running the query would get the same results from it. In other words, if I put some functions in there that might vary depending upon your language settings or your date time settings, that would not be deterministic and it wouldn't be safe to persist to disk or to index. In this case, I can persist the computed column if I want. I can also index the computed column if I want. This version of my query, I have not changed. I am running just the original query. I haven't changed anything in here to match the computed column. The computed column has a case statement in it. So I'm just like, okay, is there some magic on this first test? This is a wild shot. Is there some magic that will make you see the computed column and be able to use it? Well, some sort of opposite magic has happened. We now are up to 961 logical reads. Well, where did we start? Our original baseline of scanning the clustered index was only 482 logical reads. So we have managed to, by adding our computed columns, we have managed to make our number of logical reads go up. That seems like it makes no sense, but it actually does make sense. Let's look at the execution plan first to make sure we know for sure what index we are accessing. It is not using the new index we created on the computed column at all. It is doing a clustered index scan of ref.firstname. This operation used to take only 482 logical reads. What happened was when I created that computed column, I persisted it to disk. When I rebuilt my index earlier, I rebuilt it, and this index has a fill factor of 100. It's filling up the pages as much as possible with this first name data. And so if for every row I go in and I'm like, oh, you have another column, any if there isn't room for it, if the pages are so full that I don't have room to say, here's your other column on this page, I'm going to have a bunch of page splits happen. And I created some fragmentation in my index. I'm querying now sys.dmdb index physical stats, which lets us look at fragmentation. And I've passed in the object ID for ref.firstname. And then over a little bit to the right, I said, I want to see the data for index ID 1. That index ID 1 is the clustered index of the table if it has a clustered index. And what we see is index level 0. This index has 3 levels right now. Index level 0, that's the leaf of the index where the keys and the includes are. It has 956 pages right now, and they are only 55% full. I'm getting more logical reads because I fragmented my index, and now there's a bunch of empty space on it. And I did that by persisting the computed column. Please don't take this to mean that persisting computed columns is bad. If you are using computed columns, there are many cases where persisting the computed columns can get you better execution plans. It doesn't always work. There's edge cases galore with computed columns, but persisting it can be very useful. But in order to reduce my fragmentation, I may want to do some index maintenance. I'm going to just redo an offline rebuild, just like I did at the beginning of the demo. I do have an extra column in the table now, so I will expect it to take up a little extra room. It's not as small as it was when it started out because I have added an extra persisted column there, but now if I check again, I shouldn't have all that empty space, and I'm down to 2 levels in my index. We didn't need that intermediate level anymore, and now I have 528 pages. They are 99% full, so I won't have that much larger number of logical reads. If I run, my query again, this is going to just scan the clustered index of the table. Now my logical reads are down to 530 logical reads for the table. But what if I wanted to use the computed column? If I wanted to use the computed column, I have changed my query slightly and said I want first equal last equals 1. I have referenced the computed column by name. I'm still looking for rows where total name count is greater than 10. And I want to order by total name count descending. How does this query do if I reference the computed column? Well, much better. Now that I've referenced the computed column and said, okay, that's what I want you to use. I want cases where that equals 1, where it's true that first report year equals last report year. I am now down to 6 logical reads. And SQL Server did use that non-clustered index, the indexed computed column that I created. If I look at the properties of this, and this one's small enough, let's actually use the tooltip, I can see that it's all seek predicate here. We're seeking on first equal last as well as total name count. Everything is working like we want. We are outputting those columns that we covered. It is worth knowing that there are some more gotchas with indexed computed columns. It's going to be picky also about client settings. If the applications that modify data in this table, if they have maybe a legacy ANSI null setting, or they have some client setting that SQL Server doesn't like when it has indexed computed columns in the table, modifications may fail. In other words, the first time you deploy indexed computed columns to a particular application's tables, test it outside of production first and make sure modifications still work there. Same thing applies to index views as well as filtered indexes. I'm going to now drop this index for this computed column as well as drop the computed column. This was a persisted computed column. I am now dropping it, saying, oh, we don't need that anymore. And now I'm going to reset the table by rebuilding the index so that I don't have empty space on those pages. Because I'm measuring logical reads, I want to be fair and reset before I start testing the next query. And this time we're going to do a different flavor of computed column. This computed column might, depending on the other queries we run, it might be more useful if we were going to do a solution like this. This time I'm going to say I want to add a column named last minus first. And I have actually done first report year minus last report year here. Let's actually make it last minus first. So let's go ahead and do last report year minus first report year in here. I've already created it, so I'm going to go down and drop it. And let's recreate it to match its name. When I wrote this code, I was so excited I put them in the wrong order. We are now going to go ahead and index this table. And IntelliSense hasn't caught up. IntelliSense doesn't think this is a real column in the table because I just created it. I hit Shift-Control-R on my keyboard to wake IntelliSense thread up and say, go refresh your cache. And now it says, oh yeah, you did just create last minus first. Now that I've indexed that, let's see if our query can see that first report year equals last report year has anything to do with that column. I'm measuring my reads on here, and sure enough, my definition of my computed column is different. My query says these are equal. My computed column is finding a value for these. So I'm getting 482 logical reads for the query, which is scanning the clustered index. It is not using my computed column because I haven't made the query match to it at all. 482 logical reads is where we started out, and that is the same logical reads we're getting now that we rebuilt the index. And when I added this computed column, I didn't say to persist it, so this didn't take up space on the table. Well, what if I change my query slightly? Notice that this time, one option, I could refer to the computed column by name, but I could also do first report year minus last report year, or the opposite. Let's actually go ahead and do it this way. Because honestly, if we're looking for, the computed column makes more sense with last report year minus first report year for those names where it's been around for more than 0 years. But in this case, let's see if it recognizes that it could use the computed column, in this case, for first report year minus last report year equals 0. I'm going to highlight just the query, and I'm going to look at estimated plan. I did Control L. And with estimated plan, it's like, oh, I don't know that I could use that. Let's change the order, though. Let's do last report year minus first report year equals 0. Now I'm going to highlight the query again and do Control L. And now that the formula in my query exactly matches the formula in the index computed column, it says, oh, you don't actually always have to specify a computed column by name. It was able to see, oh, this formula, last report year minus first report year, that's present in that computed column. And look, you have an index on that computed column. I am going to go ahead and use it, and I can seek on it. I can seek on the last minus first column, which we didn't even specify by name. And I can seek on the total name count as well. Let's go ahead and run it and measure its logical reads. And this query gets us down to 5 logical reads. This one, we've saved just a little bit more. I think if I recall, the previous computed column was 6 logical reads. I'm not sure if I wrote that down or not after we ran it. Yeah, I didn't write it down. So we're going on memory there, and logical read here, a logical read there. Sometimes they fall off in my memory. So we have a couple different options with the computed columns. Pros and cons. There's not a ton of overhead on this compared to, we added a column. Now, we did have that issue with fragmentation. Now, it wasn't that the column we added was huge. It's that when we persisted the column that we added, there just wasn't room for it, and we fragmented the table and needed to go back and do maintenance. Also, computed columns do support statistics, which can be nice. However, the cons, as I mentioned, we do need to test modifications for indexed computed columns, indexed views, and filtered indexes. We need to make sure that the client setting options, things like ANSI nulls, ANSI warnings, that they don't conflict with the table, because creating these can make that matter a lot more than it did before we created them. We also may hit a bunch of edge conditions. As I mentioned, there may be times when the computed column definition of a persisted column is expanded and we're like, wait, that's persisted. Why would you do that? We may also have times if we don't persist a computed column where we just don't get a very good query execution plan. This article by Paul White is very, very helpful in learning about this. There's also a new trace flag in 2016 that can help with some of these edge cases. But if we really wanted to do this, if we were at a larger scale and this would help an important query, rather than use a computed column, in any case where I'm considering using a computed column, I'm also going to raise the question of, could we just create a normal column and then maintain it ourselves? Because then we don't have to worry about any of these edge cases, because the truth is that when it comes to query optimization, there's some weirdness that happens with computed columns, and it's not fun to get caught in one of those edge cases if we can avoid it. Well, what about other solutions? Maybe an indexed view would work. Let's make sure that I actually did drop these. And I did go ahead and drop them. And now let's try out an indexed view solution. I have called this view One Year Wonders. When I create the view, if I want to create an index on this, I need to use with schema binding. What I'm doing is I'm promising the SQL Server, I am not going to change the schema of this table. I only have one table in here in my index view. I'm not going to change the schema of this. And I am going to bind the schema. While this view is around, no schema changes. That is required if I want to make it an indexed view by creating an index on it, which we're going to do next. My query says in this view, I only care about these rows where first report year equals last report year, and where the total name count is greater than or equal to 10. I am returning first name, first report year, and total name count here. To make it an indexed view, I need to create a unique clustered index on it. It must be unique and it must be clustered. I could put, now that I have done this and persisted this view, I could create other indexes on it. I could create non-clustered indexes, but I have to first make it into an automatically updated table. This automatically updated table only contains rows where first report year equals last report year and total name count is greater than 10. So it's a subset of the rows in my table. But when a new row comes into the table, it has to check, is first report, do I need to go add this to the view? If I delete from the table, I have to check, is there data I need to delete from the view? And if so, I need to delete it. Same thing for updates. So this is automatically updated as the table or tables inside it change, which is really pretty cool. Will SQL Server use this for my query? My query is a little different than the view. My query, I alias a column as solo report year. I didn't do that in the view. Also, I am ordering in this query. I'm going to run this query, and we can see that we do, in fact, get data back very, very quickly, and with only 4 logical reads. That is a new record in our logical read counting. This is an Enterprise Edition feature where SQL Server can look at the definition of my query and see, oh, I could service this with an indexed view, so I will go ahead and automatically match to it. If I look at my execution plan, we are doing a clustered index scan on the view. It is a view clustered scan. We created a unique clustered index on our view. It is an automatically updated little table. So we are scanning that clustered index. We do not have any predicates here. The predicates are in the definition of the view. The view only contains the rows where first report year equals last report year, and there are more than 10 of them. So the predicate is, it happens when the data is modified. We don't have to have a predicate on this in the view because it is already filtered. That's what's in the table. The index view only contains these 281 rows. That makes this execution plan really simple. We do have the order by in our query that it adds to it. Now, getting SQL Server to use the indexed view isn't always that easy. This time I have highlighted simply the query without the order by. if I still have my actual plans on, if I run this query without the order by, in this case, SQL Server, my VM just froze up a little bit on display there. So that was just a display issue due to the VM, not the SQL Server. Notice that this time we don't have a scan on the view. This is not view clustered. This is clustered. It decided to just go ahead and scan ref.firstname. In theory, I actually made it match better because I took out the order by, but SQL Server just looked at this and it was like, oh, I may as well just scan the base table. And if I look at how many logical reads this is, I'm once again not including the order by, just running it like that. I only have 482 logical reads. Things get tricky with index views. Sometimes the auto matching just works. Sometimes it's weird. Sometimes it's using the index view. Auto matching is dependent upon creating statistics on the index view, and those statistics only get created if you query the view with no expand and some predicates. There's these weird things you can run into. So you do have to be careful and make sure that your indexed view is reliably getting used, even if you have Enterprise Edition, because that auto matching feature will not always kick in. I am also able to, of course, query the index view. I'm running Developer Edition, which has all the features of Enterprise. I am able to query it directly by name. If I do it like this, I am still not guaranteed that it's actually going to use the index view. It has the option to do what's called expand the index view. I have my query plans on and I run this query, and this time it does decide to scan the index view. I get the 4 logical reads query. If I run this without the order by, however, it decides to expand the indexed view, and it says, oh, I'll just go scan ref.firstname and I'll run these predicates on every single, I'll just check. I'll just do it the long way. Whoops, right? If I really want to make sure that it's going to use the indexed view, there is a way. I can say, do not expand the definition of the view. If you are using Standard Edition of SQL Server, if you're using anything other than Developer, Enterprise, or Evaluation Edition, and you want to use an index view, you must use with no expand. But it can be useful even in Enterprise Edition if I want to make sure it doesn't expand. Yes, we are really using that indexed view this time. So this query does not have the order by in it. This is the one that liked to expand, that didn't have the order by, and this query now, we have said you must use that indexed view. Let's go ahead and put the order by in just to make the results identical with our baseline, however, and we should still be at 4 logical reads. We are. No expand. Really, really use my index view. Those are the sample solutions that were my favorites for getting down to 4 logical reads. I hope that you've enjoyed this SQL challenge on indexing the one-year wonders, and I'll see you again in a SQL challenge soon. Thanks, folks. Bye.